Now they have to prove that these aren't extraterrestrial. And they also move without creating an exhaust or breaking the sound barrier. They didn't specify what other was, but you can fill in the dots yourself.
Imagine you're looking at a quiet part of space, completely still. No explosions, no supernova, just darkness. And then something flashes through, silent, fast, unexplained. In 2017, astronomers caught a glimpse of an object slicing through our solar system like a knife through velvet. It was unlike anything they'd ever seen. No comet tail, no exhaust, no heat. It didn't spin chaotically. It accelerated with no visible propulsion. They called it Oumuamua, Hawaiian for a messenger from afar arriving first. At first, scientists thought it was a comet. Then they said it might be an asteroid. But it had none of the traits of either. And now, in 2025, world-renowned physicist Dr. Michio Kaku has gone public with stunning new data. Data that's forcing the scientific community to ask a terrifying question. A messenger with no engine. Let's start with what made Oumuamua so strange in the first place. It moved like a comet, but acted like a spacecraft. As it flew through the inner solar system, it sped up, a phenomenon known as non-gravitational acceleration. Normally, this happens when comets vent gas after being heated by the sun. But when scientists pointed telescopes at Oumuamua, nothing. No tail, no venting, no dust, just acceleration. Now here's where things get wild. Michio Kaku's team recently reanalyzed the data using a cutting-edge method called quantum-enhanced optical modeling. And the results? Disturbing. The object's acceleration didn't just happen. It matched a mathematical pattern, one that precisely aligned with its spinning motion. Every 7.3 hours, as the object completed a full rotation, its trajectory adjusted just enough to stay on course. Not a hair more, not a hair less. The dead zone origin, a deliberate launch? If you think the object's behavior is strange, wait until you hear where it came from. Thanks to the Gaia Space Observatory, which maps the 3D positions of over 1.8 billion stars, astronomers were able to track Oumuamua backward, in time. The result? It didn't come from a busy star cluster or some chaotic binary system where gravity could fling it into interstellar space. Instead, it came from a dead zone, a quiet region with no known gravitational disturbances. This is significant. For an object to be naturally ejected into space at interstellar speeds, you typically need some kind of cosmic slingshot, a supernova explosion, massive stellar winds, or a complex dance between two orbiting stars. But Oumuamua's origin had none of these. No binary stars, no massive bodies, no explosions. Just calm, still space. So how did it get here? The terrifying possibility is this. It didn't escape its system by accident. It was launched. That dead zone might have been chosen on purpose. A place where its departure wouldn't raise suspicion, where no natural mechanism could mask its exit. In other words, the origin itself might be a clue that this object was deliberately sent, quietly, stealthily, toward star systems like ours. A patterned spin meant to scan. One of the most mysterious behaviors of Oumuamua was its spin. Initially, scientists believed it was tumbling randomly, as many oddly shaped space rocks do. But in 2025, a team using deep learning algorithms revealed something else, something almost impossible to explain naturally. It wasn't chaotic. Oumuamua spun with perfect precision, a 7.3-hour rotation with a variance of less than 0.002%. That's like spinning a top and having it turn at exactly the same speed for years, without slowing down, speeding up, or wobbling. Even more bizarre? Every 43.8 minutes, it made small rotational adjustments, like a machine scanning its environment. Think about that. This object wasn't just rotating. It was methodically exposing different surfaces to the sun, and possibly to Earth. When engineers saw the data, they recognized something familiar. This pattern matches controlled rotation models used in advanced spacecraft. where spinning is used to regulate temperature, optimize energy collection, and conduct 360-degree scans. The cloak of thermal invisibility. In 2017, NASA aimed the Spitzer Space Telescope, an infrared detector, at Oumuamua. At the time, it had just passed closer to the Sun than Mercury, where temperatures exceed 500 degrees Fahrenheit, 260 degrees Celsius. Any normal object would be radiating heat like crazy, and that's what scientists expected to see. Instead, nothing, no heat, no signature. It was invisible in infrared. Fast forward to 2025. Using enhanced thermal mapping algorithms, Michio Kaku's team reanalyzed the Spitzer data. And the results are, frankly, terrifying. The object absorbed solar energy, but didn't emit any detectable infrared radiation. That violates the basic laws of physics. Even the darkest space rocks radiate heat. That's how thermodynamics works. Absorb energy, and you emit it. But Oumuamua broke that rule. So, what gives? There are only a few possible explanations, and none of them are natural. One, it could be made from an unknown material with properties we've never seen, something that blocks heat emission entirely. Two, it might use metamaterials, engineered tech designed to manipulate electromagnetic radiation. NASA has been dabbling in this for stealth probes and thermal cloaks. But the third theory? It's straight out of science fiction. Intentional thermal cloaking. In other words, this object may have been built to hide from detection, like a stealth submarine in the cold void of space. Space junk or silent sensor? At this point, you might be wondering, what is Oumuamua really? Is it a spacecraft, a rock, a decoy? The truth may be more complex. In 2025, Michio Kaku and Harvard's Avi Loeb proposed a new possibility: Oumuamua as a technological relic, not a working spaceship, but a fragment of one. A piece of space debris, not from Earth, but from an alien civilization. Let that sink in. They suggest the object might be the remains of a light sail, a broken comms array, or a part of a much larger vessel, what they call a technological fossil. Think of it like alien garbage, except it's smarter than anything we've ever made. Several clues support this idea. Its extreme, cigar-like shape, 400 meters long and only 40 meters wide, matches nothing we've seen naturally, but closely resembles human-made spacecraft components. And its controlled, non-chaotic tumbling hints at a damaged gyroscope or sail, once maintained by software, now running on fumes. No signal, no beacon, just silence. This fits perfectly with the so-called litter hypothesis, the idea that our first contact with alien life won't be through a dramatic landing or glowing message. It'll come through junk, remnants, stuff left behind. And this idea, honestly, is kind of terrifying, because it means we may not even recognize alien contact when it happens. Passive probes, watching us silently. Michio Kaku's most chilling conclusion: Oumuamua wasn't just space debris or even an ancient relic. It was a passive surveillance probe. Let that sink in. Not a ship, not a broken satellite, but a functioning, intelligently designed observer, specifically made to study other civilizations without being seen. Here's the evidence. First, its trajectory was optimal for gathering intel. It didn't just fly randomly through space. It swept through the inner solar system, passing close enough to Earth to gather radio signals, electromagnetic emissions, and visual data, but stayed far enough away to avoid being intercepted or detected until it was too late. Second, the rotation pattern. Remember those 7.3-hour cycles and micro-adjustments? Engineers say they perfectly match the kind of behavior you'd expect from an intelligence-gathering probe. Something designed to scan, regulate temperature, collect energy, and relay data. Third, and this one's crazy, Oumuamua maintained a perfect listening position as it passed Earth, a According to 2025 trajectory data, it was in ideal range to receive global communication broadcasts, radio, TV, even internet frequencies for about 72 hours. A sky full of ghosts. Here's the part that will keep you up at night. Astronomers now believe that Oumuamua wasn't a one-off event. According to the 2025 analysis, if you factor in how limited our sky coverage is and how brief the detection window is for fast-moving objects like this, then the numbers tell a disturbing truth. An object like Oumuamua likely passes through our inner solar system every year. Every single year. We've only seen one because our detection systems are painfully outdated. Most sky surveys cover only about 15% of the sky, with the depth needed to spot these dim, fast-moving visitors. And objects like Oumuamua, they're even harder to detect because of their thermal invisibility and stealth trajectories, often approaching from the sun's glare, making them invisible until they're already leaving. Think about that. If just one of these objects was a probe, how many others have passed us by undetected? How many have already scanned our solar system, gathered information, and slipped away silently into the dark? Can we catch the next one? The question now isn't if another object like Oumuamua will come, it's when. And more importantly, can we intercept it? The good news? We're building better eyes on the sky. The Vera C. Rubin Observatory, set to begin full operations by late 2025, will be a game-changer with its massive 8.4-meter mirror and a 3,200-megapixel camera. It'll scan the entire night sky every 3 nights. That means we'll finally have a system that can spot fast, faint, interstellar objects weeks or even months before they arrive. And with that detection window, we could launch a mission. That's the plan behind Project Lyra, an ambitious proposal from the Initiative for Interstellar Studies. Using a gravity assist from Jupiter, followed by a solar slingshot maneuver, we could reach speeds up to 70 kilometers per second, fast enough to catch up with interstellar visitors like Oumuamua. It wouldn't be easy. It would require nuclear thermal propulsion or advanced solar electric drives, tech we're just starting to scale. But if launched within 6 months of detection, such a spacecraft could reach the target in 2 to 3 years. The next visitor might not just pass by. Here's the scenario Kaku warns about most. If Oumuamua was a scout, a passive probe sent to observe, then history tells us something chilling. Reconnaissance rarely ends the story. Whether you look at military strategy or the evolution of exploration on Earth, and if these objects are part of a larger survey effort, as the frequency suggests, then it means something, or someone, is methodically mapping our neighborhood. The open question. So here we are, at the edge of what we know and what we don't. We've covered the data, the acceleration without propulsion, the impossible spin pattern, the thermal cloaking, the dead zone origin, the AI-detected scanning behavior, the absence of natural explanation, and the frequency an object like this might visit every year. Michio Kaku and his team aren't just making guesses. They're following the math, the physics, the data. And that data says this: Oumuamua was not behaving like a natural object. Its movement, design, and silence all point to technology. Technology we don't understand. Technology we didn't build. And now it's gone. It came from nowhere, watched us silently, and left, without saying a word. And the most terrifying truth? So if you found this story fascinating, and you want to stay ahead of the next cosmic enigma, make sure you subscribe, hit that notification bell, and join us next time as we continue to explore the mysteries that challenge everything we think we know about our universe.